Let's start by reading the question for part A. A 20 kilogram object is acted on by a conservative force given by F equals negative 3x minus 5x squared with F in newtons and x in meters. Take the potential energy associated with the force to be 0 when the object is at x equals 0. What is the potential energy of the system associated with the force when the object is at x equals 2 meters? So we start by listing our givens, and we know that the mass is 20 kilograms. We know that the force function is negative 3x minus 5x squared, F in newtons, x in meters. We know that the potential energy is 0 at a displacement of 0 meters, and we are looking for the potential energy at a displacement of 2 meters. So we start this problem using the equation F, the force function, is equal to the negative derivative of the potential energy function, and we substitute our force function into this equation, and then we basically just solve for the potential energy function. And first we integrate both sides, and then we multiply both sides by -1 to get an equation, this equation here. And we know that C is equal to 0 because when the displacement is 0, the potential energy is also equal to 0, as shown in our givens. So we know that the C is equal to 0, and so then we just plug in 2 for x and solve for the potential energy, and we get an answer of 19 joules. By reading the question for part B. If the object has a velocity of 4 meters per second in the negative direction of the x-axis when it is at x equals 5 meters, what is its speed when it passes through the origin? So we'll start by looking at our givens. We're given that the mass is 20 kilograms, given that the force function is negative 3x minus 5x squared, F is in newtons, x is in meters. We're given our potential energy function that we calculated in the last problem, U is in joules, x is in meters, and we're given the initial velocity, which is negative 4 meters per second, and we're given the initial displacement, which is 5 meters, and we're looking for the final velocity. So we'll start by using the equation the mechanical energy is equal to the kinetic energy plus the potential energy, and we can calculate both the kinetic energy and the potential energy, and we'll start by doing that. So we have these equations here. The potential energy equation comes from what we calculated in the last problem as shown in our givens, and the kinetic energy equation is taken from the textbook. We then plug in our givens into both these equations to solve for E, and we get a final. In doing so, we get a final mechanical energy of 406 joules. 160 joules for the kinetic energy and 246 joules for the potential energy. And now that we know that there's 406 joules of energy in the system, of mechanical energy in the system, we know that when the particle is passing through the origin, the mechanical energy is also going to be 406 joules. And we know that the potential energy is going to be 0 because if we plug 0 for x into the potential energy equation, then we get 0. So we know that all the mechanical energy as the particle goes through the origin is going to be from kinetic energy. So we therefore set this final velocity equation equal to 406 joules, and we solve for the final velocity. We plug in our mass, and we get a final velocity of 6.4 meters per second. Moving on to question C. What are the answers to A and B if the potential energy of the system is taken to be negative 8 joules when the object is at x equals 0? So essentially this question is just asking us to repeat what we did in parts A and B. However, the initial potential energy when the displacement is 0 is actually now going to be negative 8 joules instead of 0 joules as we did in parts A and B. So the first step is to actually repeat part A. So what we're going to do is we're just going to take that equation that we obtained after taking the integral of both sides of the equation and then to multiply by -1. And now we're going to use -8 for C instead of 0 because now when we get a displacement of 0, we have a potential energy of -8 joules instead of 0 joules. So this is the resulting equation. And now what we're going to do is we're going to plug in 2 meters into this equation to calculate what the potential energy will be because we're looking for the potential energy at 2 meters. And we get an answer of 11 joules, which is actually exactly 8 less than 19 joules, which shows that our answer is correct. So for the second part, we are going to repeat the second part of the question. We're going to repeat part B. and we're going to solve for the final velocity as it's passing through the origin. So here, the kinetic energy is actually the same. We're looking for the mechanical energy of the system, and right now the kinetic energy is going to stay the same. However, the potential energy changes when we change the initial value when the displacement is 0. So what we do is we plug in 5 meters, as that's what our starting x is, and we calculate a potential energy of 238 joules. Now, to calculate the mechanical energy, we add the kinetic energy and the potential energy together, and we get 398 joules. And now that we know this is the mechanical energy of the system. So what we do in the next step is we actually are solving for the final velocity. As we know, as it goes through the origin, it's going to have the same amount. The amount of energy of the system is going to stay the same because we are told that we have a conservative force that is acting on our object. So we plug in our mass, 20 kilograms, and we solve the equation, and we get for the final velocity, and we get 6.3 meters per second as our final answer.